True. Hello, folks, again. uh, yeah, just told them to take 2 minutes before joining so that they're not like there's no information overload for them.
Yeah, makes sense.
I think we have 15 folks here.
I think in total 50. I mean, both batches will join, right?
No, I think it's only compulsory for the beginner track, and it's
Oh,
optional for those people know. Um, I, I don't think they need like an introduction to.
yeah, yeah, makes sense.
We have 20. They just started 8:34. Last 2 minutes.
Good.
Awesome. You wanna start? Um, yeah. So let me just give an introduction. So, hey folks,
Yeah.
we have Piyush with us. He was previously at Polygon and is now at Protocol Labs and IPFS, and he looks at I'd say like ecosystem growth and a lot of things. I think this session will be fun for you to understand IPFS. So,
My position is even complex. I'll let you know in a while.
yeah,
Okay, so let me share my screen and so, uh, okay. Hope you are able to see it.
yes,
Okay. So basically, my position is developer advocacy, but now I'm completely, I mean, developer advocates come under me in some sense, you can say. But yeah, even I'm handling developer advocacy part, some business development part, and some research part. So yeah, that's a different chapter altogether. So maybe we can talk about later my stuff. But yeah, you can follow me on Twitter or something like that. So this session is about introduction to Filecoin and IPFS. So first, like though I want to clear up some confusion maybe you have around these names, which used to float around Web3 ecosystem. So yeah, first is PL, IPFS, Filecoin Foundation, and Filecoin. So you have probably heard of these names, and maybe even we used to use them interchangeably, and it's not unfair to say because they are tightly affiliated, but these are actually separate organizations altogether. So basically, Protocol Labs was founded in around 2030 by Juan Bennett. It's a fully distributed open source R&D organization which builds protocols, tools, services, which aims to help, in general, radically improve the internet and drive breakthrough in computing, which can, help move us and humanity forward. So these are our big goals, becoming powerhouse and research going places crazy. Yeah, so that's in general our mission. And coming to IPFS and Filecoin, so basically these are two projects which are originally incubated in some sense, you can say, at Protocol Labs, though it was built by Juan himself. But these are open source projects, so we cannot affiliate directly. That's why we used to say it's incubated, because lots of things happen with IPFS and other storage provider solutions as well. And Filecoin is a different picture. I'll come to that later. So, but like now, as they own a separate organization, both IPFS and Filecoin, the original white papers of both was released, I think, around by PL in 2014 and followed by 2015. So basically, then IPFS splits into its own entity in 2019. Then Filecoin was founded, and then it was released, like it's testnet, then further it's mainnet, and I think more than 1 year. In this October, we'll be crossing second year of Filecoin mainnet. So while Protocol Labs continue to drive a force for research development, IPFS Filecoin operates as their own entities because they have their own separate developers, but then too they used to work very closely and stuff like that. So hopefully that clear up things around these things, these organizations. Uh, then what will be our agenda in general? Like core concepts, IPFS Filecoin, then tooling, possibilities, learning resources, and in the end Q&A stuff will be there. So starting with core concepts of IPFS and Filecoin, you might have come across this diagram a lot. Centralization, single point of failure, decentralization, multiple point of failure, distributed. Everything is connected with every other thing. So data, information, and knowledge are basically a couple of most important assets of a connected era in general sense, because they drive human development. That's why we believe they must be safeguarded, open source, and in the hands of people. But in the current model, they aren't. So let's start with the problem. Currently, the Web 2.0 model is centralized. There are only few companies that are offering storage like Microsoft, Google, Apple, Amazon in Web 2 world. If any of these fail, which they do occasionally, entire services will go down. So as you go further and further distributed, your services become more resilient, and user themselves have the power of these services. So, like, what is basically the solution of the Web 2.0 failures, and how we can build a web that is distributed, how we can get to a world that has a resilient, performant, scalable, secure, efficient, which has trustlessness, censorship resistance, thread privacy, silo busting web, and whatnot. So over the course of next, I think 40-45 minutes, we'll talk about IPFS, which is basically a peer-to-peer hypermedia protocol for content addressing. Then Filecoin, which is basically which is the world's largest decentralized storage network, and then working towards building towards it's working towards the important building block of new Web 3.0. So files and folders might sound boring, right? But really, they're not. So coming to this now, IPFS stands for Interplanetary File System. But what is file system first? Files and folders and any files which has content stands for files and stuff. Why interplanetary? But right, because it can be conceived in a way to update the web, which would still work when network stretches across planets, and that too happened recently. I'll come to that later, maybe. The idea being that if you are on Mars, let's say, it may take your file to request from Earth, and but that request will take 1 hour, and further for catching that file and bringing that file to Mars will take another hour. So it's very time consuming. But however, if that content is already fetched by someone else on Mars, then that person should just serve as a content instead of going back to Earth and catching that file again. So as we see, IPFS is distributed by design. Sorry, no central authoritative servers or storage. Sorry, authoritative servers for storing content is there. No central servers are there, which one needs to contact to obtain its content. So basically, or typically, you would upload the content to a server, a location basically. So anyone waiting to download the content will have to get it from that particular location. But with IPFS, it's slightly different. In IPFS, you run an application called IPFS Sphere. So with this, you yourself become a server. You don't have to upload content anywhere, but instead add it to your peer and make it discoverable by everyone else. So any content that is published on IPFS uses content addressing, which is a way of referencing a piece of data by its hash, rather CID. I'll come to that later. To do this, we will need to know how to obtain the content identifier, the CID part. So yeah, coming to that point. So in general computer, if we store a file, we have the path, like file specs and path and whatever file it is, we have to go to that particular file. Right. So that's a simple analogy. But when it comes to Web2, you have your IPs and stuff, and you have to go to that particular file. But now in case of IPFS, how you will obtain it from a remote location? That's the question. However, basically the difference here is we don't have the location based addressing. We have content based addressing. Like your content is what you're fetching from a location in Web2, but in Web3 with IPFS, you're fetching your content with your content part, which is CID, content identifier. So ultimately, content can be can be at one or different servers or several servers, but you just have to see from where you have to fetch it as per your need. So basically, how exactly this content becomes a CID? So you have your content, right? So in order to get the content addressable things rather than location, we need to create content identifiers of each piece of information, that we put on the IPFS peer-to-peer network. So you can think of it as a cryptographic fingerprint of that particular piece of content. And each piece of content produces a different fingerprint, in general hash, because it's a hash phenomena itself that every content will have its own alphanumeric key or something like that. And if we change a single thing in content, your hash will change in a huge manner, which is called avalanche effect. Even I've come from a cryptographic background. Like I have done lots of work on these and stuff, so I know it very in depth. So yeah. So basically, these fingerprints are of same size in general sense, regardless of the amount of content. These are hashing principles, basically. So this fingerprint, which we named as content ID, can be reproduced any time from the original content. Again, hashing phenomena that from content, you can just generate a hash. Not the reversible thing can be done. It's a one-way function. So this means if you obtain a piece of content after requesting a content CID, you can just verify by doing the exact, getting the exact same thing. But what about folders? So same work for folders, because folders are basically a special type of files only, which has list of files in that folder as content. So that list provides the name of those files, and in that case of IPFS, these are CIDs. Since the folder is also a type of file, CID can be obtained in the exact same way, but the thing will be a little bit different. Here we will have a content addressable structure, just like this. So basically, on the right hand side, on the top level, you have the root CID, right? So root CID is basically it has all things into like all tree structure or Merkle DAG. DAG stands for distributed, directed acyclic graph. So Merkle root or Merkle DAG of this particular graph structure has the core content CID of the complete structure, in sense you can understand. So it has two entities, in sense you can corresponding to two folders, and those folders have other entity corresponding to files in the end. So each entry has a different fingerprint that is here visualized by colors. Uh, so basically, the content address type of graph is what we call as Merkle DAG. DAG stands for directed acyclic graph. So these Merkle DAG used by IPFS allows to move from location-based addressing to content-based addressing in a single step. So we can just replace locations with the root CID of the content, and the subpath stays the same. But what will happen, let's say, if we wanted to copy file.txt to a folder of second user? It means two things. Firstly, we don't actually have to copy the file. We just have to modify the folder's reference of content. So basically, how IPFS CID used to work. Let's say you upload a similar image onto IPFS, you'll get a same CID again and again. So then too, you will get a same CID. So basically, it used to just point to that CID. So yeah, in a similar manner, it will work here. And this property is called as deduplication. Secondly, since we have changed a folder, the fingerprint of that folder will be changed. So of course, the top level root CID will change as a ripple effect. So right, so in fact, like that CID will always represent exactly the same piece of information, unlike a location. So which definitely unlocks the capacity of doing verification of piece of data at any point of time. That matters because if CID is guaranteed to you, uh, I mean, with the same content, you don't have to get the content from a trusted or centralized server. You can ask anyone for CID, anyone in the network, regardless whether you trust them or not. Now, the first step when you add content to IPFS, what exactly happens? Basically, that content is divided into chunks or pieces, you could say. These pieces are converted into hash. That's why I'm not saying CID is hash, because there are different CIDs of these chunks. These chunks can be stored in different peers. And like what your CID is, it is referencing all the peers, sorry, all the chunks, and getting back to you. So yeah, I mean, with that particular CID only, you can able to retrieve your content. But what is peer and what exactly it does? So peer is like peers is basically a peer-to-peer system of nodes that are connected towards other peers in the form of network or swarm. So forget about IPFS for a moment. Think of it as a group of people. if I want to address a person and communicate. So, I mean, how I will be able to identify that person with its name, right? So, if we share a common language, so then only we can communicate. If we are PK, then we are not able to communicate, right? So, since with IPFS and peers in the network, each peer has its unique CID, which is called as unique identifier. Sorry, my bad. Every peer has its unique ID, which is called as peer ID. The the identifier is linked to cryptographic identity, which allows each peer to communicate securely through encrypted channel. Of course, encryption requires it because if things will lost in between. The peers in the IPFS network are basically peers who support a set of services and or a protocol. So one of them is to request certain content of CAD from a different peer and download it. So basically, in order to get these things between peer need to able to discover each other. So they just used to ping other peer, hey, what all content you have? Just like the network transport stuff, the TCP upload, something like that service. So this is the step. This step basically is called content and peer routing. It is achieved by something called as or using something called as DHT, distributed hash table. This is particularly the distributed hash table where each peer used to ping other, hey, what all content you have? So that particular content with its value can be stored in his DHT. So it's basically a table which is was critically to run this particular each peer run this DHT table, and they used to ping each other via something called as gossip protocol, just like a gossip in real world. Same gossiping here happens here. That every peer used to ping other, hey, what all content you have? Then he used to ask to other, and they used to maintain a table like that. It's efficiently, it's efficiently a series of key value pairs. So it's just like names with phone numbers. So in order to get associated to a key, for example, the content ID, a peer will need to find some other peers that is storing it. That's the way they used to maintain the DHT. So this process consists of asking other peers who has that key value and stuff like that in the random fashion. That is how gossiping works, right? So peers with certain name or peer IDs are more likely to store certain key value pairs. Thus, a peer knows basically which of the peer is connected to the most likely one who has that particular key and stuff, its value. And if it doesn't have, then it will request information from other peers known by the other peers, which is likely to have it. Now that we have a database which is maintained collectively by these peers, but how exactly it is used by IPFS? Simple, like when the content added to IPFS, a peer will insert a row in a DHT, right? So like two things happen, right? A peer provides a specific CID and how it is connected with their peer IDs. So that's the way they used to do the mapping here and generate to the peer ID, declaring themselves provider of that content. So publishing of row involves finding enough to that content ID to store the row. At the end, in general sense, DHT queries appear know who has the content, what he wants, and where to get it from. So yeah, that's how content discovery used to work. Now that we have gone through obtaining a CID, advertising it on the network and locating the content is important. So let's take a brief look at transferring that content. That is done by something called as BitSwap. It's basically a protocol of service instance, you can say, which is supported by IPFS peers. It's specific for like IPFS, which allow requests to a content addressable ID or piece of the information, whatever you want from other peer. It's just 3 steps. Ask that peer that he has the CID or not. Then copy or data transfer used to happen. And then they used to verify that is it asking the same or not. That's how this content transfer works. Now, like IPFS is useful to anyone in sense who wants to serve or retrieve content on the web, which is almost everyone. As a certain piece of content get more popular, the data became more readily available and resilient. But why would random people would store my digital content? You might have come across this question, right? The answer is they likely wouldn't, because they are not. There is not any incentive mechanism here, right? And you're kind of losing the beauty of decentralization and trustlessness because of this single parameter. So if their servers goes down, your data will be, data may be temporarily or permanently inaccessible. That's why we have come with an alternative solution called Filecoin. Before that, there are some pinning services available like Pinata and Fura. So they used to pin these CIDs and get back to you. But these are also centralized. That's why Filecoin come into play. So let's start talking about Filecoin. So Filecoin is basically designed for the Web3 for ground up of storage needs and in general sense verifiability and persistence of your data. So it's compatible with IPFS and other existing Web3 smart contract technologies like Polygon, Near, Solana, and other ecosystems as well. It's cryptographically verifiable, so you can store your CIDs on any blockchain. Uh, you know, really or reliably retrieve the same data every time, and then like provided like they used to have some storage deals which one needs to make to store it on Filecoin. Like right now, we have around 16 exabyte of storage. Uh, I mean, it's 16.8, but I think later this year, 17 exabyte, I think 20 exabyte will happen because we are an open network, so anyone can become a storage provider. But yeah, it should. Okay. Does anyone have any question or so? Oh, okay. Yeah. So that's a capacity, basically 3% of whole data we have right now, and what Google used to have in 2015. So that's enough capacity for every use cases across the organizations and people using Filecoin to store data. Even I'll come to some use cases later on. Yeah, I think 18 is mentioned there. Yeah. Okay. So let me talk to you about the analogy of Filecoin storage deal and how it used to happen. So there are two consensus mechanisms here. One is proof of replication, which provides or proves the storage provider is storing a unique copy of your data. Second is proof of space time, which proves data is stored continuously over time. So a battle of these, a battle between different storage provider happen for these two consensus mechanisms, and they win further. So like for storage provider, they must have to stake Filecoin as their as collateral to dissuade malicious activity. Because let's say any storage provider, let's say if we have stored a term Filecoin, but at a particular time that storage provider is not able to give that particular file to us, so as collateral, which is Filecoin, will be slashed. So yeah, I mean, storage provider buy a Filecoin, like File token, put it up as a collateral, must have an internet connection, this space, and get paid or earn to store and retrieve the data. So storage providers, the user providing storage and retrieval services, which are called as storage providers. It is basically miners only. but just because of mining word itself is banned in China. So we have, manipulated it. So, compute, they used to compute on storage, as I mentioned, because reliability and speed matters for any open source based market. Just a supply and demand mechanism. So that is used to work. I think, yeah, I've covered it. Okay. So for permanence, any storage deal can be renewed an infinite number of times. Uh, so just these deals used to happen again and again. Like that can be done by smart contracts. And for redundancy of your data, let's say if you want to have uh, a copy of 10 copies of your file on Filecoin, that too can be happened. So you can do multiple storage deals and replicate it. But like IPFS itself is a layer agnostic. It works like it just provides the power of CID or the magic of CID, which we used to say. So like magic of CID is general sense they are property of data itself, which makes them storage layer agnostic, which allow them to fully flexibly available and for modularity. So the fact that it's storage layer agnostic means that you can combine with storage layer of your choice. You can store it on IPFS, and then for the you'll get the CID. For the storage layer can be Filecoin, which is of course a great option. But then too, you can even go for other decentralized solution or even centralized solution on top of it. Like I mentioned, pinning services like Pinata. So IPFS and Filecoin basically are perfect match, perfectly complements each other. So IPFS is a great way to fast, and flexibly retrieval over the IPFS network, and can be accessed through HTTP gateways for users who are not well equipped with the web websites which are available in IPFS. Though IPFS needs somewhere to persist data. That's why Filecoin answers that question for persistence and verifiability through distributed storage deals, which any storage provider can accept. All right, like I promised I would tell you some tools which you can take help to make your app. So I'll go through that few of them from now. But before that, let me walk you through this, like about storage and retrieval data. Right, we highly recommend choosing a storage helper. They simply deals and workflows, making it fast and easy to build. So the yellow layer, that is what I'm mentioning about. They simply basically make deals in background, but you don't come across these things. And the pricing negotiation, everything happens in background for you. So waiting for confirmation, verifying storage deals, like it's a very long process in background. But yeah, you just get it in a second. So yeah, I mean, just in nanoseconds or something. So you can store it on both IPFS and Filecoin with just a single call via some API keys. So let's dig into that. First is Fleek. It's a solution for hosting website. There is another solution, Spiron, which is also for hosting websites on top of IPFS and Filecoin. So it's your website will be live on IPFS, just like Netlify and Web2. These two solutions are available for Web3 website hosting. So you can deploy your website on Fleek. Further, what will happen in background, it will be uploaded on IPFS and backed up on Filecoin. Same goes for Spiron. But yeah, Spiron directly uses S3, which is a solution or node service for both IPFS and Filecoin. I'll come to that later. So with Fleek, you can use GitHub Actions just like you use in any other service, any centralized services like Netlify. So GitHub Actions are available here, and It's very simple to use. So you must check it out if you haven't. Another is Web3 storage. So basically, Web3 storage is a powerful solution for hosting your any data, and it's I mean right now it's free, which is backed over Filecoin and available over IPFS seamlessly. So data is immediately uploaded to uh, hosted S3 node. That what I mentioned, right? So S3 is basically a node of both IPFS and Filecoin. In fact, like it used to help you to make track the deals for storage provider. Almost like they used to, in general, used to store it for 6 providers around the world, and it can even vary depending on your needs. Even you can include HTTP APIs and other web interfaces, some remote pinning services. Let's say if you are using some centralized services, then do you want to back your data on Filecoin as a guarantee, as an insurance? So that too is available here. Right now, like 1 TB tire is free, but in this quarter, we are coming up with some business dynamics in Web3 storage. So yeah, further it will not be free. Like yeah, but I think 1 TB then 2 will be available for free. Let's see. Now NFTload storage. It's again a powerful solution. It's a sister tool of what Web3 storage used to provide. It's free and it will be free forever. So backed up, your data will be backed up on Filecoin. It will be available on IPFS, same just like that of Web3 storage. It's just a specific use case friendly. And we want to make it as a public good. So later this year, it will become a DAO. So its backend can be, some DeFi mechanism with DAO will be there so that anyone can come and donate to that ecosystem. But yeah, that's a different case. Right now, we have onboarded across around, around 70 million NFTs. You can even check out at NFTload storage/stats. So it is around 70.4 million NFTs right now. And it's just started a few months back only. So yeah, you can get a 8x redundancy, and even you can increase it as per your need. And of course, deal making will be there forever. So yeah, in some sense, you can understand insurance stores as a insurance policy for your NFTs. So your NFT will be live forever on Filecoin. Like let's say there are also some existing, some folks are using IPFS first to get the CID and pinning it via Pinata or stuff like that. So that's why remote pinning service is even available here. If you even want that remote pinning service, I can even give you some brief description about it, and even get you assigned easily, just in a matter of seconds. Because I used to work with these team closely. So in general sense, NFTload storage is a solution for every NFT. Either it's on centralized version, then two, because rug pulls used to happen. I think just tomorrow, I think today itself, if I'm not wrong. Yeah, today itself, a very huge case happened for rug pulls. So basically, rug pulls is the thing, like you have your NFT on a centralized service. Let's say a Bored Ape, right? Your metadata is available on a centralized server, but the owner of it has changed the metadata of it, and it has made it as a mat. So your NFT's value is nil now, right? So that's why these rug pulls, this is basically a rug pull story. You can check it out later on. That's why we used to push NFT storage very heavily, and yeah, it was very limelight at NFT NYC as well. Now, Lighthouse, which itself is a decentralized solution for storage, and it is for like you just have to pay it once, and it will be stored forever. Like the permanence thing is simple with Lighthouse, just like what is done by Aviv, but like Lighthouse is a competitor of Aviv. So Lighthouse has a different model, uh, lots of different things which differ himself from Aviv. It is using Filecoin. Further, it is permanent solution. Its price is very cheap than compared to that of any other solution in the market. It has some other dynamics as well, where some data DAO is there, where these whole tokens are stored. But with Lighthouse, these tokens are even available on Polygon and Ethereum, and these are even earning from there, and further it is distributed. So it's a very great platform to explore. You should check out files.lighthouse.storage. If you didn't get access, let me know. I can give you the access, or I can talk with Nandit from Lighthouse team, because Protocol Labs is invested into Lighthouse. So then comes Filecoin Green. Just like that, Polygon has launched its green solution for decarbonizing the complete chain. We even have Filecoin Green, and I think one hackathon for uh, sustainability of Filecoin is running right now, which will end around 2 weeks from now, or I think 1 week only. So you should check that out as well. So APIs or stuff, if you're making any things around making simpler for any storage provider to make himself green. So that grant is available. I think it's $1 million grant that is available for lots of things. I can even give you a link later on. You should even check out greens.filecoin.io. Now OrbitDB. So if you come across any distributed database, OrbitDB will be one of the very great database. But it's currently in active development, so you can check it out for simpler use of some demo apps. But I will not recommend you to go for a very good app. So there is another another DB available, ThreadDB, which is by our great ally Textile team. Even OrbitDB is doesn't come in the Protocol Labs, but it is using IPFS, so it comes under our stack. So yeah, I was talking about ThreadDB. So ThreadDB is built by Textile team. But yeah, I haven't explored much about ThreadDB yet. But yeah, ThreadDB is even crazy. Like lots of solution I have seen which are building on top of ThreadDB. So yeah, you should check it out. PowerGate, coming to Textile itself. So PowerGate is basically a Dockerized version of both IPFS and Filecoin. There are lots of bridges as well. Okay, I think it's an old thing. I have to remove it because they are no longer maintaining the bridges. So yeah, I mean there are already near ETH and Polygon bridges available, but yeah, they are not no longer maintaining it. But if you want to check it out, I can give you the bridge access. Now Filspan, it's basically how you have used the Amazon S3 buckets or something like that. So it's compatible, API service, which is compatible with Amazon S3 cloud as well. Because, many folks used to have a question how we can bridge our data from Amazon or AWS in general sense to Filecoin. So this is one of the bridge. You can check it out. Further, there is another thing I think I haven't mentioned. Yeah, S3. I was talking about S3 before. So S3 has another service. I just have faced this pick very recently, just in a matter of start only of a session. So basically, there is another service available in S3 called rclone. So with rclone service, you can onboard your AWS data to Filecoin very easily. Like there are some commands and stuff through which you can do it. Yeah, but it's a deeper level thing. So maybe you should check it out. And if you come across any doubts, let me know. Then use cases around these stuff. So metaverse and gaming and Hurdle One is a great platform. You might have come across it. So Hurdle One is a video streaming service. They even have their SDK, which is going crazy. And I think Hurdle One is. I think we should do our meet from Hurdle One itself because it's a Web3 native video streaming platform. So yeah, it's crazy. Maybe you guys should start it off. Then Audius, it's I think yeah, one of my mentees even mentioned about Audius. So it's a music streaming platform. It's on IPFS. Just like you can upload it on upload music to TikToks or any other things as well. So yeah, you should check it out. Currents FM, it's even a very great platform. Inflow Music, like in general, music platforms are crazy. But yeah, Audius is one of the crazy projects I personally have seen. But yeah, it is not backed up on Filecoin. So yeah, for NFT use case, but yeah, it's again Mona. Mona is a metaverse. It's on both Polygon and Filecoin. if you know go into Mona very deeply, these guys are crazy. They are doing everything on their metaverse. I think it's the only metaverse who has the largest amount of you know tools, and I would say largest amount of artilleries available in their metaverse. So maybe you can check it out. Like the 3D art mechanism is even crazy. OP games, again a common between Polygon and Filecoin. Metaverse AI is a great project. Like IPFS and Filecoin is not just limited to blockchain use cases. We are beyond that, right? If AI use cases there, IoT use cases there, so it comes across every sector and chain agnostic. So Block Beast is another solution. Like music platforms are crazy with that. That's a dancing platform. Then consumer storing and verifiability use cases like Curo Digital is a great platform. Filter, it's a filter available for platform. Then Nifty, so Nifty even another service, Nifty Safe is even coming down the line, which will be like a indexing service on top of Filecoin. So yeah, that's even crazy. But yeah, Nifty itself is a it's a platform. It's a fractionalized ownership of your NFT. So yeah, the convo space. I think Ankit, remember this person, Anudit. I think yeah. So
Yeah,
Anudit
yeah, I know that.
made this.
He's one of the
Yeah,
builders. Yeah.
yeah, he's a crazy builder, no doubt on. So the Convo space is built by him. I think it's he has started after his fellowship last time. So yeah, it's a crazy project. Or maybe in fellowship, I was not aware of. I'm not
Yeah,
aware
yeah.
of.
He started off with in the Build India Fellowship, and then
Yeah,
took it ahead from there. Yeah.
yeah. Even Protocol Labs has invested into this particular stuff. So he's doing crazy things out there. Then again some other use cases like Slate. I've mentioned about Fleet. Chain safe files, yeah, it's very close to me because I love the gaming and NFT space. So chain safe files are even coming up, already there with their APIs, and it's even a common thing for Polygon and Protocol Labs. And Protocol Labs is very heavily, doing work with chain safes. Even chain safe is running a particular node called Forest. So there are different nodes like in different languages. One is Lotus node, which is basically a Filecoins node which you can run on your desktop as well, but it's very heavy. It's even complex than that of running any other network node. Yeah, rather than naming it Ethereum or so. Yeah, but Chainsafe Files is doing their API keys are very crazy. You should check it out. I would recommend you to check it out. I think lots of games are even building on top of it, and I think their 20 GB free trial is even available. So yeah, it will be easy to check you out. Numbers protocol is another use case. I think it's on different chain, but yeah, you should check it. But finance and bio, secured finance, Visa finance, Parcel, Redix, like platform are endless, right? Like for data set, one of the crazy which I every time used to excited about is Internet Archives. It's available on IPFS. The complete Internet Archive is available here. Then the Schwab Foundation is doing stuff. Uh, you know, then climate change data, forestry data. It will come under five country now, but yeah, I think things are crazy. So possibilities are endless, but I think whenever Web3 enabled architecture is there, so there are several layers and application, but this yellow layer is the key. Above that, any smart contract system can come. Of course, Polygon is the most preferred one for everyone in the market. So yeah, and later this year, some huge things will even come into play, which is called as FVM, Filecoin Virtual Machine, which will be fully compatible with EVM. And I mean, EVM compatibility is, we are running the EVM compatibility right now. So, it will be very useful for data DAOs and other stuff in the future. So, yeah, that's it. So, like, finally, like, in general sense, like, IPFS and Filecoin is there. No one interact directly with them. They used to interact via these storage helpers, either via NS3.storage, Web3.storage, textile teams, any solution, S3. Space is basically a Fleek service, which is the next level thing for Fleek. So you might check that out. Then there are logic layer, the smart contract and front end is there. So yeah, the back end is removed. So there are more solutions like Ceramic is there, then Infura is there, then lots of other storage helpers are also there. So yeah, of course, possibilities are endless. So you should check it out. Like some of the project ideas, these are very basic project ideas, though, like social media websites. Like many folks have done that stuff, but it is on very deeper level of how PubSub used to work. Like PubSub is a public subscriber service available on IPFS. You can create a group of 3 or so and interact between them via this service. So yeah, it's crazy thing. Then chess, of course, Battle.net last time was very chess friendly just because of Samarana and video streaming platform. I think we even need video dot storage where you can store directly your video. Maybe like there are some services available on top of IPFS like DTube, but I think they're not that much effective. So if video dot storage will be there, then it can be embedded into any platform. So that will be crazy. And I think I can give you a very huge grant if you come up with something called as video dot storage. But yeah, that should be compatible with NFT dot storage or something like that. Catch the Planet is a great thing, like how Google is storing things. So similarly, if you can do it something like that RSS simulator, many folks have built these things. Archives, even we want archive dot storage where like Internet Archive, we are doing it with them, but maybe with unability of Filecoin. If archive dot storage will be there, that is a crazy thing I personally want to see. Then Snapshot. So Snapshot is basically a service which many folks used to build in hackathons as well. So let's say if you want to see any particular platform at a particular like IPFS or any lib2p GitHub repository. So you want to see it for a particular instance. So I mean, these snapshots will enable that stuff. Well, that's even a crazy thing to do. Distributed metaverse, believe me or not, uh, for metaverse, folks are crazy. Even companies are crazy. Web3 companies are crazy. So if you can do some things on metaverse, I'm sure you're getting a good grant. So hot coffee, cold coffee, it's a very simple thing, but if you can do it with some other stuffs, that can lend you a grant. So check it out as well. GitHub platform. I mean, there are some platforms available. I think Radical is available, uh, but I think we want a very Git friendly, decentralized platform. So that is not present there. So yeah, I mentioned about decentralized YouTube. So DTU is already there. That's why we want a video dot storage for streaming services. Of course, Livepeer is doing great job, no doubt on it. And even there are many other streaming platforms. But let's say if you come up with some things which is directly using Filecoin, yeah, that will be exciting to me as well. So yeah, possibilities are endless. I think you should work on this stuff, hardware and other stuff, maybe at some other level. But yeah, of course, smart contract will be there. So yeah, as per you, as per your need, you can do it. And learning resources, if you want any learning resources, then complete IPM's blog itself is there. Then we are maintaining multiple schools. One is proto.school. Proto School is all about IPFS, Filecoin, and our stack. So basically, there are multiple things, right? IPFS is there. So IPFS is divided into 3 pieces or 4 pieces. Like IPFS is there, then lib2p is separated out, which is a network layer. IPLD is separated out, which is a data layer. Multi-formats is a different thing, which I don't want to cover even because I just know basic about it. So multi-format is a different thing which is separated out. So IPFS is a great in its own right. But when this separation happened, so after this, their development was very crazy. So IPLD itself is going crazy, and Filecoin itself is a blockchain. But later this year, FVM will be there. So lots of different possibilities can come into place. So yeah, I mean, you can join our Slack. Slack is completely open, or our IPFS Discord, because both are connected. So either of them you can join and ping us on community channels. And yeah, I think I have taken a huge time. But if you have any questions, let me know. Any idea how many nodes are there on Filecoin network? Okay, around the nodes, I'm not sure, but I'm sure about storage provider. There are about 4,000 storage providers right now. But we, it's a Filecoin is an open network, and we believe in increasing the nodes. So I think later this year it should reach up to 7,000. So yeah.
Hi Piyush, I had a doubt in content addressing.
Yeah, please go.
Like, how are we supposed to request some CID? Like, if we don't have the file itself from which the CID is going to be made.
Mhm. So that's what peer used to do, na? Like you have the CID, right? You get the CID, you store it on Filecoin, sorry, IPFS, you get the CID, right? Now comparing things will work. Like you have the CID, now you'll compare, you will send it to peer one, let's say. That peer will search across its network or its distributed hash table and give back to you that this is the CID, and then you can retrieve back the folder or file in general sense.
Right.
So
Okay.
there are lots of protocol working in between. I haven't come across that stuff. So in general sense, let me give you nitty-gritty. So basically, a file divided into chunks. First thing happen is hashing, hashing of these chunks, right? So these chunks are stored in different pairs, and further your CID is generated, right? So it's a long process. It's not a simple thing, right? As I mentioned, I think I have to go slide. Just give me one second. Where is the tab? Any of these? So, the first one. Yeah, I need one more. So yeah, basically you will obtain this thing, right? Further, every peer is connected with each other, so they're getting the distributed hash table. So every DAG, or sorry, every distributed hash table will have CID with its reference content. So you just have to compare your CID, and you'll get the pointer to that particular content. Hope it resolves your doubt.
Yeah, I got it. And like on a similar lines, like my question was more like, if I want to like visit Wikipedia or org, so I would search that. But over IPFS, like if I want to search a file that I have not uploaded on IPFS, so how would we go about doing that?
It's public. Like you can go it via gateways, right? You should have the CID. You can go with the HTTP gateways or DWeb gateways, and you can get it. But I mean, I think you are coming across privacy stuff, so even I can answer that stuff. Let's say I don't want my content to be discoverable to any other. Yes, you just have to encrypt it and store it because IPFS itself is a public network.
Right, got it. Yeah.
Yeah, cool.
Hi Piyush, this is Ankit.
Yeah. Okay.
So my question is, so I have downloaded IPFS companion, so I think that makes me a
Mhm.
peer in the network.
Yeah, for sure. Even your Brave browser is a peer. You can play with your Brave browser.
Okay. So actually, I was trying to download a file. I had the CID, and
Uh-huh.
so what I noticed that even though my network was pretty strong, like the internet connection was pretty strong, but still it took like 10 to 15 seconds. So on further digging, I saw that IPFS uses something called tit for tat strategy that I guess BitTorrent also uses, where like if you are more sharing, then you have like more rewards in terms that you can download faster. So is it that, or still IPFS? It's getting built, and that's why the download was a bit slow.
So the thing is, like, your companion will be there, right? You have installed your companion, but the thing is, it should be added to the public network. Then only you will be able to get the public peers accessible to you. So that's why it has taken time for the first time, right? But maybe if you will access again, so it should get it early. But there are some gateways available in IPFS through which you can access file easily. Even IPLD itself as a data layer. So through IPLD, I think great restructuring are happening in IPLD itself. So I can assure you, maybe end of this quarter itself, some great things are going to announce, which can make your experience more faster. But I think with IPFS gateways, even lots of NFTs are using that stuff. So yeah.
Okay, got it. And the thing that you told about my IP getting listed in the public thingy. So I think it won't get listed over there because I'm behind my provider, and so it has its own
Yeah,
IP.
in some sense you can understand in that way, but yeah, it's very deeper thing.
Okay, thanks.
Even personally, I got 1 month or so to understand that stuff in my beginning. So yeah.
Okay.
But I will recommend a video to you because you have asked this question. I'll give it to you later on, maybe.
Okay.
Or I can give it right now.
Yeah, you can put
So
it on the chat.
basically, yeah. There is a like we have a getting started page, so you can look into the IPFS big dive that is done by Steven, and that should be sorted thing. If you want a Juan's video, but yeah, I think Steven video should be will be good because Juan used to give videos around 2 to 3 hours. So I think you should start with this. Maybe further I can give the Juan's video around complete IPMS perspective. It's around 2 to 3 hours video. Yeah.
Okay, got it.
Cool. Maybe we can take one last question because we're kind of done. Maybe one last question,
Yes.
if there's anyone else.
Yes, someone had said.
Yeah. So am I audible?
Yeah, you're right.
Yeah.
Yeah. So my question is, so basically, is there a current way to basically restrict someone from accessing a media file? So,
Okay, I was having the same question.
So you can block the gateways. That's it. That is the thing you can do, but you cannot. I mean, sorry, I can get 2 parts of it. So what kind of restriction you want?
so basically, so if there's a smart contract NFT project who have deployed some, let's say, Bored Ape, so anyone else can do the same thing, and anyone else can get the basically IPFS URL and point to the same collection. So
Yeah,
basically,
for sure.
yeah, for that kind of restriction.
So, okay, so that's what I've mentioned, right? IPFS itself is a public peer-to-peer service. So no one can restrict it. But the restriction, you have to do it, let's say if you don't want to access your file. So you have to upload it in an encrypted manner so that anyone else cannot, access it. So,
Is there any
yeah.
is there any like private storage solution available?
It's available. Like you can run your own IPFS private nodes and plug and play, but that will not be available in public. So you have to
Right.
run your private node fully. Otherwise, let's say if you're not running at a particular time, then your data will be lost because you're not using any pinning service and it is not available in the public ecosystem or public peers.
Okay, got it, got it.
And
So
many folks are running this stuff. So yeah.
yeah, so just to clarify, so if I run a private node on IPFS, that data would still be accessible to others, or no?
No, that will not be available for anyone else.
So
Uh, uh,
either I can have it all private, either I can have it all public.
An encrypted manner so that anyone cannot access that. Yeah, two things are there. Yeah, and I thought you were mentioning that let's say if there is any bad thing, something like pornography, where governments want to ban something, so no one can ban anything on IPFS, but the thing is they can ban the gateway from which this thing is accessible because on IPFS it's available. Yeah.
So by gateway, the centralized gateway, right?
Yeah.
But they can technically make another gateway to the same CID and bypass it, right?
Yeah, but that too can be banned.
Yeah, but it's like a mouse and cat. Okay, yeah, but I got what the point is.
I mean, there are lots of things which folks used to come up with for these kind of stuff. So yeah.
Yeah. Got it.
All right. I think we can call it a wrap. Piyush is also on our Discord. He's a primary mentor for a cohort. So you can definitely, if you still want to engage with him in a conversation, anything about Filecoin, IPFS, protocol labs, just tag him on Discord in the relevant channel. He'll be able to take it ahead. And Piyush, thanks a lot for taking up this session. I think it was quite.
Thanks for
It was a
having me.
good. Yeah, it was good. Deep dive into how Filecoin IPFS is helping the Web3 ecosystem, and yeah, much appreciated, Piyush.
Even my Twitter is open, so if you don't want to follow, then too you can come up with on my Twitter. So my Twitter is hi you share. So yeah, you can ping me there as well, or on Discord I will be available.
Awesome. Yeah. Thanks a lot, everyone else, for joining, and I think we can call this a wrap.
Okay then, see you guys. Bye bye.
Thanks, Piyush. Bye bye.